Now let's do problem 3D of exercise 1.3. Problem 3D. Alpha prime equals alpha squared and beta prime equals beta squared. Alpha prime plus beta prime will be equal to alpha squared plus beta squared, which is equal to alpha plus beta all squared minus 2 alpha beta. So if we slot in figures, we see that alpha prime plus beta prime equals minus 5 over 2 all squared minus 2 into minus 2, which is equal to 25 over 4 plus 4. This implies alpha prime plus beta prime equals 41 over 4. Alpha prime beta prime equals alpha squared beta squared, which is equal to alpha beta all squared, which is equal to minus 2 squared. That's equal to 4. And our new equation is given by x squared minus into alpha prime plus beta prime x plus alpha prime beta prime equals 0. So if we substitute for alpha prime plus beta prime and alpha prime beta prime in this relationship, we will have substitute for alpha prime plus beta prime and alpha prime beta prime above. We have x squared minus alpha prime beta prime equals 41 over 4. 41 over 4 all over x. Alpha prime beta prime equals 4 equals 0. So if we further simplify, we'll have 4x squared minus 41x plus 16 equals 0. And that is our new equation. So, given alpha and beta are the roots of 2x squared minus 5x minus 4 equals 0. Clearly, a equals 2, b equals minus 5, and c equals minus 4. Recall, alpha plus beta equals minus b over a, and alpha beta equals c over a. This implies alpha plus beta equals minus 5 over 2, and alpha beta equals minus 4 over 2, which is equal to minus 2. Now, if alpha prime equals alpha squared and beta prime equals beta squared, then sum of roots will be alpha prime plus beta prime, which is equal to alpha squared plus beta squared, equal to alpha plus beta all squared minus 2 alpha beta. If we slot in values for alpha plus beta and alpha beta, we have alpha prime plus beta prime equals minus 5 over 2 all squared minus 2 into minus 2, which is equal to 25 over 4 plus 4. The thing which results in alpha prime plus beta prime equals 41 over 4. Alpha prime beta prime equals alpha squared beta squared, which is equal to alpha beta all squared, which is equal to minus 2 all squared, which is equal to 4. And our new equation is given by x squared minus into alpha prime plus beta prime bracket x plus alpha prime beta prime equals 0. If we substitute for alpha prime plus beta prime above, we have x squared minus 41 over 4x plus 4 equals 0. On further simplification, we have for the 4x squared minus 41x plus 16 equals 0, and the solution is complete. Jot down some points. Now let's do problem 3E. Now, given that problem 3E, alpha prime equals alpha cubed and beta prime equals beta cubed, our new sum of root will be alpha prime plus beta prime equals alpha cubed plus beta cubed, which is equal to alpha plus beta all cubed minus 3 alpha beta into alpha plus beta. If we substitute these values into this relationship or this relation, alpha prime plus beta prime will be equal to minus 5 over 2 all cubed minus 3 into minus 2 into minus 5 over 2. which upon further simplification gives us minus 125 all over 8 minus 3 times minus 2 is 6. 6 times minus 5 is minus 30 over 2, which gives us 15. 15 times 8 is 120, so that gives us minus 125 minus 120 all over 8, which is equal to minus 245 all over 8. Alpha prime beta prime is equal to alpha cubed beta cubed, which is equal to this to close. So let me take this off. Alpha prime beta prime is equal to alpha prime beta prime is equal to alpha cubed beta cubed, which is equal to alpha beta all cubed. This gives you minus 2 all cubed, which is equal to minus 8. Our new equation is given by x squared minus into alpha prime plus beta prime. X plus alpha prime beta prime equals 0. So if we substitute for alpha prime and beta prime above, plus beta prime and alpha prime beta prime above, we have x squared minus into minus 245 over 8 x minus 8 equals 0. If we further simplify, this will yield 8x squared plus 245x minus 64 equals 0. And that's the solution to problem 3a. Now let me explain this further. Given alpha and beta are the roots of 2x squared minus 5x minus 4 equals 0, clearly a equals 2, b equals minus 5, and c equals minus 4. Recall, alpha plus beta equals minus b over a, and alpha beta equals c over a. This implies alpha plus beta equals minus 5 over 2, and alpha beta equals minus 4 over 2, which is equal to minus 2. Now, it is given that alpha prime equals alpha cubed and beta prime equals beta cubed. So alpha prime plus beta prime will be equal to alpha cubed plus beta cubed, which is equal to alpha plus beta all cubed minus 3 alpha beta into alpha plus beta. If we slot in figures for alpha plus beta and alpha beta, we have alpha prime plus beta prime equals minus 5 over 2 all cubed minus 3 into minus 2 into minus 5 over 2. This gives us minus 125 over 8 minus 15, which yields minus 245 over 8. Alpha prime beta prime, please. Alpha prime beta prime equals alpha cube beta cube, which is equal to alpha beta all cubed. This is equal to minus 2 all cubed. A thing which results in minus 8. Our new equation is given by x squared minus into alpha prime plus beta prime all into x plus alpha prime beta prime equals 0. Substitute for alpha prime plus beta prime and alpha prime beta prime above. We have x squared minus into minus 245 over 8 all into x minus 8 equals 0, which on further simplifying gives us 8x squared plus 245x minus 64 equals 0, and the solution is complete. Now let's go to problem 4 of exercise 1.3. Problem 4, solution to problem 4. If the problem reads, if one root of the equation mx squared plus nx plus q is twice the other root, show that plus q equals 0. Show that 2n squared is equal to 9n cubed. Now, given alpha and beta are roots of the above equation, beta is equal to 2 alpha. Clearly, A equals M, B equals N, and C equals Q. Problem 4 continues here. Recall. Alpha plus beta equals minus b over n, minus b over a, and alpha beta equals c over a. C equals q here, please. Required to prove. Required to prove. Two n squared equals 2m cubed. Now we know from this that alpha plus beta equals minus n over n, and alpha beta equals q over n. But beta equals to alpha. This implies alpha plus beta equals 3 alpha, which is equal to minus n over n. From this, we see that alpha is equal to minus n over 3m. And with the product, from the product of root, alpha beta equals alpha into 2 alpha, which is equal to q over n. This implies 2 alpha squared is equal to q over n. Let this be our equation 1. This implies alpha squared equals q over 2n. Which implies alpha equals the square root of q over 2n. Let this be equation 2. Equating equation 1 and 2. Equation 1 equals equation 2. implies minus n over 3n is equal to the square root of q over 2n. So if we square both sides of this relation, this will give us n squared over 9m squared is equal to q over 2m. Please correct this. 2n squared must be equal to 9m cubed. That's what we are required to prove. 9m cubed. So if we cross multiply, we see that this results in this goes away first and this goes away. So if we cross multiply, this will give us 2n squared is equal to 9m cubed. And our proof is complete. QED. So this is the proof. Now this is how the question reads. If one root of the equation mx squared plus nx plus q equals 0 is twice the other root, show that 2n squared equals 9m cubed. Now, given alpha and beta are roots of the above equation, beta is equal to 2 alpha. Clearly, a equals m, b equals n, and c equals q. Recall, alpha plus beta equals minus b over a, and alpha beta equals c over a. Required to prove 2n squared equals 9m cubed. Now if we take the sum of root alpha plus beta, that will be equal to minus n over m, and alpha beta will be equal to q over m. But beta is equal to 2 alpha. So this implies alpha plus beta equals 3 alpha, which is equal to minus n over m, which results in alpha being equal to minus n over 3m. And alpha beta equals alpha into 2 alpha, which is equal to q over m. This results in 2 alpha squared being equal to q over m, which implies alpha squared equals q over 2m. Upon further simplifying, it gives us alpha equals the square root of q all over 2m. Now, if we equate equation 1 to equation 2, this yields minus n over 3m minus n over 3m equals the square root of q over 2m. Squaring both sides yields n squared over 9m, n squared over 9m squared equals q over 2m. So this m cancels this, so that remains, that gives us n squared over 9m equals q over 2. If we cross multiply, this gives us 2n squared equals 9m cubed, and our proof is complete. Jot that down. Now let's do problem 5 of exercise 1.3. If alpha and beta are the roots of problem 5, alpha and beta are roots of mx squared plus nx plus q equals 0. Find without solving this equation the equation whose roots are. First, clearly A equals M, B equals N, and C equals Q. Recall, alpha plus beta equals minus b over a, which is equal to minus n over m, and alpha beta equals C over A, which is equal to Q over N. Now problem 5a reads alpha prime equals 1 over alpha and beta prime equals 1 over beta. So in this case, the sum of roots will be alpha prime plus beta prime equals 1 over alpha plus 1 over beta, which is equal to alpha plus beta over alpha beta. Substituting these figures in here will give us minus n over n all over q over n, which is equal to minus n over q. Alpha prime beta prime will be equal to 1 over alpha times 1 over beta, which is equal to 1 over alpha beta. This implies alpha prime beta prime equals 1 over q over n, which is equal to n over q. Oh, yeah, let's be careful here. Oh, this is supposed to be q over n. And this is supposed to be q over n. Yeah, that cancels itself. So this is supposed to be q over m over q. So that's all right now. Now our new equation is given by x squared minus into alpha prime plus beta prime x plus alpha prime beta prime equals 0. So if we substitute these figures into this will give us x squared minus into minus n over q x plus n over q equals 0. Now if we further simplify, this will give us qx squared plus nx plus n equals 0. And that's the solution to problem 5a. Given alpha and beta are roots of mx squared plus nx plus q equals 0. Clearly a equals m, b equals n, and c equals q. Recall alpha plus beta equals minus b over a, which is equal to minus n over m, and alpha beta equals c over a, which is equal to q over m. Problem A goes states thus: alpha prime equals 1 over a and beta prime equals 1 over b. This implies alpha prime plus beta prime equals 1 over alpha. Alpha prime equals 1 over alpha and beta prime equals 1 over beta, which implies alpha prime plus beta prime equals 1 over alpha plus 1 over beta, which is equal to alpha plus beta all over alpha beta, which is equal to minus n over m all over q over n, which results in minus n over q. And alpha prime beta prime equals 1 over alpha times 1 over beta, which is equal to 1 over alpha beta. This implies alpha prime beta prime equals 1 over q over m, which is equal to m over q. A new equation is given by x squared minus into alpha prime plus beta prime into x plus alpha prime beta prime equals 0. So if we substitute respective values for alpha prime plus beta prime and alpha prime beta prime into this relation, we have x squared minus into minus n over q x plus m over q equals 0, which on simplifying gives us qx squared plus nx plus m equals 0. And the solution is complete. So jot the solution down. Now let's do problem 5b. Problem 5b, alpha prime equals alpha squared and beta prime equals beta squared. The sum of roots will be alpha prime plus beta prime equals alpha squared plus beta squared, which is equal to alpha plus beta all squared minus 2 alpha beta. So if we slot in the respective figures for alpha plus beta and alpha beta in this equation, for this relation, we have alpha prime plus beta prime will be equal to minus n over n all squared minus 2 into q over n, which gives us n squared over m squared minus 2 q over m, which results in alpha prime plus beta prime being equal to n squared minus 2nq over m squared. And alpha prime beta prime alpha prime beta prime will be given by alpha squared beta squared is equal to alpha beta all squared, which is equal to q over m all squared. That gives us q squared over m squared. And our new equation will be given by x squared minus into alpha prime plus beta prime x plus alpha prime beta prime equals 0. So if we slot in the figures above, we will have x squared minus into n squared minus 2mq all over m squared x plus q squared over m squared, which is equal to 0. So if we further simplify, this will give us m squared x squared plus into 2mq minus n squared x plus q squared equals 0. And our solution is complete. And our solution is complete. So what we'll do here is alpha and beta are roots of the equation mx squared plus nx plus q equals 0. Clearly, a equals m, b equals n, and c equals q. Recall, alpha plus beta equals minus b over a, which is equal to minus n over m. And alpha beta equals c over a, which is equal to q over m. Now alpha prime equals alpha squared and beta prime equals beta squared. So alpha prime plus beta prime will be equal to alpha squared plus beta squared, which is equal to alpha plus beta all squared minus 2 alpha beta. So if we substitute for alpha plus beta and alpha beta, in this relation, we have alpha prime plus beta prime equals minus n over m all squared minus 2 all over q, 2 times 2 into q over m, which yields n squared over m squared minus 2q over m, which on further simplification gives alpha prime plus beta prime equals n squared minus 2mq over m squared. Now alpha prime beta prime equals alpha squared beta squared, which is equal to alpha beta all squared, which is equal to q over m all squared, a thing which is equal to q squared over m squared. And our new equation is given by x squared minus alpha plus beta all squared into, x squared minus into alpha prime plus beta prime into x plus alpha prime beta prime equals 0. So if we substitute for alpha prime plus beta prime and alpha prime beta prime into this relation, we have x squared minus into n squared minus 2mq over m squared all into x plus q squared all over m squared equals 0, which on further simplifying yields m squared x squared plus into 2mq minus n squared into x plus q squared equals 0. And the solution is complete for that. Now let's do problem 5c of exercise 1.3. Alpha prime equals problem C. Problem 5C, alpha prime equals alpha cubed and beta prime equals beta cubed, which implies alpha prime plus beta prime equals alpha cubed plus beta cubed, which is equal to alpha plus beta all cubed minus 3 alpha beta into alpha plus beta. So now if we substitute these figures inside there, for alpha plus beta and alpha beta, we have alpha prime plus beta prime equals minus n over n all cubed minus 3 into q over n into minus n over n. This yields alpha prime plus beta prime equals minus n cubed over n cubed minus plus 3n cubed over m squared, which on further simplification gives us mn cubed minus n cubed all over m cubed. And alpha prime beta prime equals alpha cubed beta cubed, which implies alpha prime beta prime equals alpha beta all cubed, which is equal to q over m all cubed, which is equal to q cubed over m cubed. Now, x squared minus into alpha prime plus beta prime x plus alpha prime beta prime equals 0. So if we slot in those figures, if we substitute for alpha prime plus beta prime and alpha prime beta prime in this relation, we have x squared minus into 3mn cubed minus n cubed all over n cubed x plus q cubed over m squared equals 0, which upon further simplification yields m cubed x squared minus into 3m n cubed minus n cubed into x plus m cubed equals 0. And this is our resulting equation. So let me explain it a bit. This is the solution to problem 5c. Given alpha and beta are roots of mx squared plus nx plus q equals 0. Clearly, a equals m, b equals n, and c equals q. Recall, alpha plus beta equals minus b over a, which is equal to minus n over m. And alpha beta equals c over a, which is equal to q over m. Now, problem C reads, alpha prime equals alpha cubed and beta prime equals beta cubed. Alpha prime plus beta prime will be equal to alpha cubed plus beta cubed. Correct, please. Alpha cubed plus beta cubed, which is equal to alpha plus beta all cubed minus 3 alpha beta into alpha plus beta. This implies alpha prime plus beta prime on some further substitution is equal to minus n over m all cubed minus 3 into q over m all into minus n over m, which results in alpha prime plus beta prime equals minus n cubed over m cubed plus 3n cubed over m squared, which is equal to 3mn cubed minus n cubed over m cubed. Alpha prime beta prime equals alpha beta all cubed. Sorry, alpha prime beta prime equals alpha cubed beta cubed, which is equal to alpha beta all cubed, which is equal to q over m all cubed. That gives us q cubed over m cubed. Q over m all cubed gives us q cubed over m cubed. Please correct this, there's an error here. Q cubed over m cubed, please. So now we know that Our new equation is given by x squared minus alpha prime plus beta prime all into x plus alpha prime beta prime equals 0. So if we substitute these values, that's the values for alpha prime plus beta prime and alpha prime beta prime into this relation, we have x squared minus into 3mn minus n cubed all over m cubed into x plus q cubed over m cubed equals 0. If we further simplify, this gives us m cubed x squared minus into 3mn cubed minus n cubed x plus q cubed equals 0. And our solution is complete. So that's that for problem 5. You can jot down the notes. Now let's do problem 6 of exercise 1.3. Problem 6 reads, the roots of the equation x squared minus mx plus 4 equals 0 differ by 2. Find the possible values of m. So given the equation x squared minus mx plus 4 equals 0 has roots with roots alpha and beta, where beta equals alpha plus 2. Clearly, A equals clearly A equals 1, B equals minus m, and C equals 4. Recall alpha plus beta equals minus b over a, and alpha beta equals c over a. This implies alpha plus beta equals m. Alpha plus beta equals m, and alpha beta equals 4. But beta equals alpha plus 2. This implies alpha plus beta equals 2 alpha plus 2, which is equal to m. Which results in 2 alpha being equal to m minus 2, and alpha being equal to m minus 2 over all over 2. Let's note this as equation 1. And alpha beta will be equal to alpha into alpha plus 2 which is equal to 4. So wherever we find alpha, we substitute this value. Let's take this to be equation 2. Substituting for alpha in 2, we have m minus 2 all over 2 into m minus 2 all over 2 plus 2 equals 4. This implies m minus 2 into m minus 2 plus 4 equals 16. Which implies m minus 2 into m plus 2 equals 16. If we continue this way, first let me explain before rubbing off the board. Given x squared minus mx plus 4 equals 0 with roots alpha and beta, where beta equals alpha plus 2. Clearly a equals 1, b equals minus m, and c equals 4. Recall alpha plus beta equals minus b over a, and alpha beta equals c over a, which implies alpha plus beta equals m and alpha beta equals 4. But beta equals alpha plus 2, so if we substitute that inside this, we have alpha plus beta equals 2 alpha plus 2 equals m, which further goes down to 2 alpha equals m minus 2, implying alpha equals m minus 2 over 2. That's equation 1. Now product of root alpha beta equals alpha into alpha plus 2, which is equal to 4. Substituting for alpha in 2, we have m minus 2 over 2 into m minus 2 over 2 plus 2 equals 4. And further if we simplify it further, it yields m minus 2 into m minus 2 plus 4 equals 16. The thing which yields m minus 2 into m plus 2 equals 16. Now we'll continue this way because I'm going to rub off the board. Solution to problem 6 continuous. Now m minus 2 into n plus 2 equals 16 implies m squared minus 4 equals 16. Which implies m squared minus 20 equals 0. This gives us m squared equals 20, and m is equal to plus or minus the square root of 20, which can further be simplified as plus or minus 2 root 5, and that's the value of m. The solution moves from here to here. Take note. So we see that on substituting all these values, the resulting equation in terms of m will be m minus 2 into m plus 2, which is equal to 16. And this results in us having m squared minus 4 equals 16. If we bring this way, it becomes m squared minus 20 equals 0, but it's a simple square, so we can transpose the other way. So that gives us m squared equals 20, and m equals plus or minus root 20, which is plus or minus 2 root 5. And that's the end of exercise 1.5. You can jot down the solution. Okay. Now let's do some useful transformations. Take note of these useful transformations. Section 1.4. Some useful transformation. One, alpha squared plus beta squared equals alpha plus beta all squared minus 2 alpha beta. 2, alpha cubed plus beta cubed equals alpha plus beta all cubed minus 3 alpha beta into alpha plus beta. 3, alpha to the 4 plus alpha beta to the 4 equals alpha plus beta to the 4. Minus 4 alpha beta into alpha plus beta all squared plus 2 alpha beta all squared. 4, alpha to the 5th plus alpha to the 5th, alpha to the 5th plus beta to the 5th, I'm sorry, equals alpha plus beta all to the 5th minus 5 alpha beta into alpha plus beta all cubed plus 5 alpha beta all squared into alpha plus beta. 5, alpha to the 6 plus beta to the 6 is equal to alpha plus beta to the 6 minus 6 alpha beta into alpha plus beta all to the 4 minus 15 alpha beta all squared into alpha plus beta all squared. It continues down here. Minus 2 alpha beta all cubed plus 24 alpha beta squared. Now take note of these useful transformations. This will help you in finding new equations whose roots are either alpha squared, beta squared, alpha cubed, beta cubed, alpha to the 4, beta to the 4, alpha to the 5, beta to the 5, alpha to the 6, beta to the 6. So take note, alpha squared plus beta squared is equal to alpha plus beta all squared minus 2 alpha beta. Alpha cubed plus beta cubed is equal to alpha plus beta all cubed minus 3 alpha beta into alpha plus beta. 3 alpha to the 4 plus beta to the 4 is equal to alpha plus beta to the 4 minus 4 alpha beta into alpha plus beta all squared plus 2 alpha beta squared. Alpha to the 5th plus beta to the 5th is equal to alpha plus beta all to the 5th minus 5 alpha beta into alpha plus beta cubed plus 5 alpha beta all squared into alpha plus beta. Alpha to the 6 plus beta to the 6 equals alpha plus beta all to the 6 minus 6 alpha beta into alpha plus beta all to the 4 minus 15 alpha beta all squared into alpha plus beta squared minus 2 into alpha beta cubed plus 24 alpha beta all squared. Take note of that, and next time we'll do inequalities. Our next topic will be inequalities. I think we are done for today. Goodbye, and take good care of yourself. Study hard.